Hey guys, hopefully chapter 5 went okay for you. You should have just wrapped up that hand in, and you will be happy to learn that this is the last section that deals with trig. So after chapter 6, you don't have to ever look at trig again until university, but yeah, so this is usually a light at the end of the tunnel for some kids in pre-calc 30. So chapter 6 is all about trig identities. So what I have done for you is I uploaded into the classroom the formula sheet that you would normally get on a departmental. So this is what it looks like. Okay, so if you haven't done so already, find this in the Google Classroom and print it off. We're mostly going to be using, see how it says trigonometry and trigonometric identities. Okay, this whole section, there's a pile of stuff there. We are going to be using that. So today, what we are going to go through are kind of three groups. So we're going to go through, I guess, this first group of trig identities. Okay. So that's where you can look. I'd print that formula sheet out so you kind of have it beside you when you're doing these questions, okay? Because honestly, I don't have those memorized, and I've been doing this for a little bit, okay? So make sure that's always handy. We're gonna go through this first group today, and we'll eventually get to those last two groups, okay? So with 6.1, we look at a trig identity. So basically that just means something that's true for every value of x that you would throw in there. Okay, so there's three identities we're going to look at today. The first one is reciprocal identities. Okay, reciprocal simply just means 1 over something. All right, so our reciprocal identities were cosecant, which we know is 1 over sine, secant, which is 1 over cos, and cotangent, which is 1 over tan. Okay, those ones are really straightforward. They're called reciprocal because they're 1 over our initial trig identities. Okay, so usually most people have those ones memorized. Okay, the next identity we will look at are quotient identities. So this just primarily deals with tan. Now, tan, we know, is sine over cos. Okay, so if you can remember that, you can remember that cotangent, right, which is the reciprocal of tan. So you literally just take it and flip it if it's the reciprocal. So cotangent is cos over sine. Okay, again, you'll always have that beside you, so you don't need to memorize, but I'd say those are good ones to know. All right. Now, when it comes to memorizing, these Pythagorean identities, these ones at the bottom, are a little more difficult. But yeah, you don't have to memorize, obviously. I said that about 10 times already. So Pythagorean identities, these simply look like cos squared theta plus sine squared theta equals 1. Okay. Cotangent squared theta plus 1 equals cosecant squared theta. And 1 plus tangent squared theta equals secant squared theta. So you're going to see those into action. Actually, probably not. I'm just looking at my notes. Probably not so much in this video, but in the second half of 6.1, so the second video, you will quite a bit, okay? So I guess you probably could pick up from that there's going to be 2 videos. This section is a little bit long, but I do find it important, especially for anybody going into university math, like taking a higher up math. You're definitely going to have to prove some of these things. So it's important that you know what they are. All right. So without further ado, let's go into a question. So we're not going to be dealing with those identities too much right off the bat, but this question says, determine the non-permissible values in degrees for the equation secant theta equals tan over sine theta. Okay, now non-permissible values, if you remember from pre-calc 20, I actually just taught this to them in a video like 2 days ago. Non-permissible values is when your denominator equals 0. Okay, so when your denominator equals 0, or any value that makes the function undefined. Okay, or any value that makes it undefined. All right, so when you do these questions, it's important you have them written in simplest form first. And then after you have it written in simplest form, we can look for our non-permissible values. So secant is not in simplest form because we know that secant is 1 over cos, right? So I'm just going to write that as 1 over cos, and then I'm going to leave this tan theta over sine theta. Okay, so now I have kind of 3 parts to this question to find when the denominator equals 0 or any value that makes that whole thing undefined. So let's just start by looking at our denominators, okay? So I have 2 denominators. I have cos and I have sine, right? So I need to find what values of cos are 0, right? Because 1 divided by 0 is undefined. And same thing there. Tan divided by 0 would be undefined too. So I need to find values of cos and sine that are equal to 0. So an easy way to do this is just go into Desmos, okay, and pull up, I'll just start with the cosine graph, okay? And we need to figure out where cos equals 0. Okay, well, that's pretty simple, right? I can just tap there. Well, that equals 0. That equals 0. And I can do this forever, right? That equals 0. And it goes both ways forever, correct? Okay, now I guess in the question, I think it said to do this in degrees, right? Right there. So I should be in degrees in Desmos. Sorry. Now I gotta do a bunch of shifting here. There. Okay. And let's just pinch it a little bit. Perfect. So there is my cosine graph in degrees. Now there you can see what values make it 0, right? Where it touches my x-axis at 0. So 90, right? 90 would be an answer right there. 270 would be an answer. 450 would be an answer. And I could keep going forever. Likewise, if I went this way, right, I could go that way. And if I hopped backwards, I went to negative 90, and then I could keep going that way as well. Okay, so you need to figure out, because that's happening periodically. So if I'm taking 90 degrees, and I'm plussing or minusing, let's just figure out, what am I adding to 90 to get 270? 180. Good. Right? And to go from 90 to negative 90, what am I subtracting? I'm subtracting 180, right? So 90 degrees plus or minus 180. Now, because it happens periodically, right? It could keep going. It keeps jumping. We always just put an n in brackets because you could put any number in there. All right. So this is going to be your non-permissible value for cos. Okay, just cos. So we only actually did one part of this question. Okay, so we just did this part right there. So I'm just going to write it over here. So 90 degrees plus or minus 180 n. Okay, that was one of them. Now let's look when sine equals 0. Okay, so when sine equals 0, because we're still looking for non-permissible values, I'm going to pull up my sine graph. Okay, now this one's going to be a little different. All right, so I'm just going to do this in a different color. I'm not going to take the time to erase. So let's look when sine equals 0. It equals there, 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 and again, it can go on forever. Okay, so it equals 0 at 0 degrees, plus or minus, what am I jumping to get to the next one? I'm adding 180, right? Or if I went backwards, I subtracted 180. So that makes sense. And then because it happens periodically, you just put the n. Okay, so that is the second part of this answer, wherever my slides are. So 2 was 0 degrees plus or minus 180 N. Okay, good. And then the last thing that's really important, okay, and kids always forget this, is we looked at our denominators, which is perfect, but anytime you see tan, okay, anytime you see tan, you should be alarmed. Okay, because tan itself, whether it's in the numerator or denominator, has a non-permissible value, okay, or multiple, right? Because if you look at the graph of tan, do you guys remember those asymptotes that we had, right? So this is your trig graph paper that I gave you for tan, right? So you had these asymptotes, which means those are non-permissible values for tan, okay? So looking at those, you literally just have to write what those asymptotes are. So pi over 2 is the same thing as 90 degrees. Okay, so 90 degrees. And then the next one was 3 pi over 2. 3 pi over 2 is the same thing as, does anybody know? 270 degrees. Okay, so if that occurs in that, like periodically, that could go on forever. 270 minus 90 is 180, right? So my, I guess, non-permissible values for tan would be 90 plus or minus 180 N. Okay, so I have 3, I guess, so that would be my third. 90 degrees plus or minus 180 N. Okay, so kids often ask, Miss Burscheid, but these two are the same, number 1 and number 3. And you are correct, they are the same, but you wouldn't have known that they were the same until you did all 3, right? So technically, in an answer, you would just have to write 2 of them. It's not like you need to write that third one and repeat it, right? But I just do that so you make sure that you never forget tan with your non-permissible values, okay? All right, I know that was a lot, but I hope that makes sense, right? Non-permissible values when your denominator equals 0, so that's what we found. And then we also had to look at tan, because tan is always special because it has those asymptotes, and those are also non-permissible, okay? So this second part of the question says, verify that theta equals 60 degrees and theta equals pi over 4 are solutions to the equation. So you will want to get your calculator out, okay? And all you're going to do, we'll do it for degrees here, and we'll do it for radians over here. So we'll start with this 60 degrees. So you just have to plug 60 degrees into here. So do you have a secant button on your calculator? No, you do not. So you need to go 1 over cos 60 equals, and then you have a tan and a sine button. So you can just write these ones. Tan 60 over sine 60. Okay, so in your calculator, you're going to type 1 divided by cos 60. Make sure you are in degrees, and you should get 2. Okay, and then you are going to type tan 60 divided by sine 60 in degrees, and you will get 2 again. So that's just verifying. All right, pi over 4 we are going to do. Keep in mind, pi over 4 is the exact same as 45 degrees. So again, put it into this. So cos pi over 4 equals tan pi over 4 over sine pi over 4. Now, what mode should your calculator be in this time? It better be in radians or you're going to get the wrong answer, okay? So go 1 divided by cos pi over 4, and you should get 1.414, or if you have a lovely calculator, it will just say root 2. Those ones are the best. And then tan pi over 4 divided by sine pi over 4 is root 2 as well, or 1.414. Okay, so that also verifies. So you're good to go. All right, I am going to stop this question. The next part there just says use technology to graph it, but we don't need to do that, okay? We just kind of verified it before. All right, so I'm going to do one more question that deals with non-permissible values, okay? So non-permissible values in radians this time, okay? In radians. So there's my expression. Cotangent x over cosecant x cos x. So like I said, it's always the best, or I find it the best, to write, you can either write them out separately, or you just need to figure out where your non-permissible values are going to be. So you're going to have non-permissible value here, right? Because that will make my denominator 0. You're going to have a non-permissible value there, right? So let's start with those. So cosecant x is the same thing as 1 over what? Sine. Okay, so when this is undefined, that means this is going to be undefined. Okay, so we need to find when sine x is 0, or sine is 0, because that would be in 1 divided by 0. And can we do that? Nope. So back to my Desmos, back to my sine graph. Here we go. This is in teal. Okay. So where was sine equal to 0? Well, we had just literally did this. It was equal to 0 here and here. And we came up with 0 degrees plus or minus 180 degrees. But this question is in radians. Yes. So do you guys know how to, I guess you could, if you want, you could simply take this and go into the wrench here and change it to radians. But you should know by now that 0 is just still the same, 0 in radians. But 180 degrees is pi, right? So that's going to be our answer there. Okay. So instead of 180 degrees, we're just going to write pi. Okay. So back to here. So this is going to be 0 plus or minus pi n. All right. So that one's good. Let's look at cos x. So when will cos x equal 0? We also did this one before. Oh, what am I doing? Okay, so cos x. When will cos x equal 0? Back here we go. We also did that one. So cos x was my purple, right? So if you look at the purple I had, or magenta, it was right there. Okay, so that's when cos x equals 0. Again, we are in radians. So instead of 90 degrees, it's going to be pi over 2 plus or minus 180 is pi, right? And then the n. All right, so pi over 2 plus pi n. So we're going to go back here and write pi over 2 plus, or minus, sorry, pi n. All right. And last but not least, we have this little cotangent here. So cotangent is the same thing as 1 over tan. Okay. So we need to find when tan x equals 0. Okay. So when will tan x equal 0? Tan x equals 0. Not when is tan x undefined. Okay, just when tan x equals 0. This is different than the last one because it's cotangent. So back to my graph paper that I had given you, we now need to look when is tan 0. Okay, and this is different. So it's 0 there, it's 0 there, and it's 0 there. And that goes on forever. Okay, So it's 0 at 0. And then what are you adding? Plus or minus. So this one is pi. So you're adding 180 degrees. So we are in radians. So I'm going to use pi n. Okay, so that's going to be what I write for my tan or cotangent. Okay, so tan x equals 0 at 0 plus or minus, oh God, now what did that say? 0 plus or minus pi n. Okay, so those three things, this one, and this one are your answers. And again, the one does repeat, but you would have never known that without doing it all. Okay? All right, so that is non-permissible values. I am going to do this last little section and then I'm going to shut up, okay? So the last part there says simplify the expression. So simplifying is my favorite thing to do. It just, I just love it. I don't know why. Maybe because kids don't like it. Okay, so we're going to take cotangent x over cosecant x cos x. Okay, and now my hint to you whenever you are to simplify something is write in terms of cos and sine. Okay, you don't want to see tan in there, cos x or sine x. Okay, so you don't want to see tan, you don't want to see cotangent, you don't want to see your reciprocal identities, just write as cos or sine. Now, cotangent, can we write that as cos or sine? Well, if you look at your formula sheet, okay, cotangent right here is cos over sine. You guys see that? So we're going to write that. We're going to say cos x over sine x. Okay, that is just cotangent. Now I still need to put another line for my denominator. Now cosecant is the reciprocal of sine. If you did not know that, you could look here and go, oh, there's cosecant and it's 1 over sine. So we're going to write that down here. So that's 1 over sine times. Now cos, that is in terms of cos or sine, so we just leave it. Okay? And then the last thing we're going to do is simply do the multiplication. So we can't do anything in this numerator anymore. Okay, that's as simple as it gets. But we can multiply this, right? This is like saying over 1, right? So when you're multiplying fractions, top times top, bottom times bottom. So 1 times cos is cos, sine times 1 is sine. So you're going to get cos over sine. So in the end, you have cos x over sine x. And then in your denominator, you have the exact same thing. Cos x over sine x. Now, what do you know? Like if you had the same thing over the same thing, what does that equal? If you had the same thing over the same thing, what does that equal? Well, you have the same thing over the same thing. So what does that equal? Yeah, so that is simplified, whether you want to believe that or not. Okay, so I'm going to stop my video right now, and I am going to give you a question to do in your textbook that deals with non-permissible values. Okay, so this is on page 296. And we are going to just simply do number 1, A and B. So page 296, number 1, A and B. Okay, just do those 2 questions. You just need to look at non-permissible values, and then I am going to do another video for the rest of chapter 6. Now, don't freak out, but chapter 6 is going to take us, it might take us 2 weeks. Okay, I know that's a long time, but I think it's important that you know it. All right, so I'm not going to rush. Like if you watch this video in one night, just watch it. And then tomorrow or in the next day, I want you to do the assignment. Okay? So don't try and cram everything into 1 or 2 days because you'll be very overwhelmed. All right? So there you go. That is the start. Hopefully that goes okay. I know this is definitely more challenging, and I do wish I could just see your faces, but this is what we got to do. Okay? So let me know if you have any questions. Please, please, please. All right? Bye-bye.